Hey guys and gals, Mrs. Hoekstra here, working on Module 1, Lesson 8, Representing Proportional Relationships with Equations. I am on page 28, so make sure you're on page 28, and let's start by writing our essential question of the day. Remember, this tells us what we're going to know by the end of the class. By the end of this lesson, we should be able to answer this question, right? What I want to know is, how could we use what we know about the constant of proportionality? How could we use what we know about the constant of proportionality? Gotta spell it right. Proportionality, there we go. To write an equation. All right. How can we use what we know about the constant of proportionality to write an equation? So ultimately, by the time we're done, we should be able to write equations. All right, your mother has accelerated onto the interstate to begin a long road trip, and you notice the low fuel light is on, indicating that there is a half a gallon, not a half a tank, half a gallon. Let's underline that. There is a half gallon left in the gas tank. The nearest gas station is 26 miles away. Your mother keeps a log where she records the mileage and the number of gallons purchased each time she fills up the tank. Use the information in the table to determine whether you're going to make it to the gas station before she runs out. That's ultimately what we want to know. Are we going to get there, or are we going to be pushing the car into the gas station? All right. So first thing you have to do, your mom's like, okay, grab my calculator, grab my phone, and get the calculator on my phone, and let's start figuring out this constant of proportionality. Now remember, constant of proportionality is the letter K. Remember I said that? K is equal to Y over X. Now I know in class several of you had asked, hey, which one's X, which one's Y? Generally, X is the one that's given first, and Y is the one that's given second. Also, Y is the dependent variable, right? It's dependent on the number of gallons of gas you have, right? This one would be called independent. This one's independent, the other one is dependent, because it depends on the number of gallons that you actually have in the car. So we're going to keep track of the miles driven. This is how we're going to do our constant over the number of gallons. All right, so that's how I'm going to set up all of these to calculate that. So the first one is 224 over 8. And when I grab the calculator, you type it in, you got 28. And then we did the next one, 280 over 10, and that's 28. And I take 112 and divide by 4, and guess what I get? Yep, that's right, 28. So your mom's car has a constant of proportionality of 28. Okay, 28 miles per gallon, MPG, miles per gallon. She's getting pretty good gas mileage. Write equation or equations that will relate the miles driven to the number of gallons of gas. So what we're going to do is we're going to take this equation up here, and we're just going to kind of move things around. Okay, that's really what we're going to do. We're just going to move things around. So K is equal to Y over X. That's an awesome equation. It works if I want to find K. But what if I want to find Y? Okay, I want Y by itself. Well, if you notice, Y is being divided by X. The opposite of dividing by X is to multiply by X. And if I multiply the right-hand side of the equation by X, I also have to multiply the left-hand side of the equation by X. What happens when you do that is X divided by X, they cancel each other out. And over on the left-hand side, we now have K times X, and that is equal to Y. Now I can solve it for Y. So I know how many miles per gallon mom's car gets. I know how many gallons we just put in the car. I know how many miles we can drive before we have to go get gas again. All right? Well, let's suppose I don't know how many gallons mom just put in, but she's got this device in her car, like my car has, where it tells me how many miles I can drive before I run out of gas, right? And it constantly is counting down. So let's suppose I want to solve for X instead. So I'm going to take K is equal to y over x. That's the equation that we start with. And instead I want to get x by itself. Well, I'm going to do like I did a minute ago. I'm going to multiply both sides by x. All right, and the x's over here on the right-hand side are going to cancel because x divided by x is just 1. So now I have k times x equals y. And you're like, Mrs. Hoekstra, we just solved that. You said you wanted x by itself. You're right, I do want x by itself. So what I'll do is now I'm going to divide this side by k. So when I do that, these two k's on the left-hand side cancel out because k divided by k is just 1, and I'm left with x. And so I have x is equal to k times y. All right? So now I've got a bunch of different ways I can use this equation. Now remember, though, a minute ago, k was 28. Right? So really I could say x is equal to 28y, or I could come way over here and I could say 28x is equal to y. So now I've got a bunch of different equations that are going to help me to solve some problems. Knowing that there is a half of a gallon left, remember we said that at the beginning? Half a gallon left in the tank when the light comes on. Will she make it to the nearest gas station? Right? Well, which one is gallons, x or y? Look back at the table. Gallons is the x. X equals gallons. And how many gallons do we have in this problem? We have a half of a gallon, right? Given to us in the story problem. So what I'm going to do is I'm going to plug it into that equation right there. So let's take 28 times the 1/2 that we're going to plug in from the situation, from this problem, and let's figure out how many miles we can go. So what is half of 28? Yeah, 14 miles. And how far away did we say the gas station was? Look back at the top of the page. The gas station is 26 miles away, right? Oof. Do you have enough gas to get to the gas station? Nope, not enough gas. Not enough gas to get to the station. You're going to be alongside the road calling for help. All right, use the equation to determine how far your mother can travel on 18 gallons of gas. Let's suppose instead, before she got on the highway, she filled up her car, 18 gallons, which, by the way, 18 gallons, that's a really big vehicle because most vehicles don't hold that much. But let's suppose that's the case. So y is equal to 28x because I want to know the number of miles, right? And y is the number of miles. So I'm going to say that y is equal to 28 times the 18 from the problem because that's the number of gallons. Remember, x was gallons. So I grab my handy dandy calculator. I type in 28 times 18 and I get 504 miles. That's a pretty good trip. Probably wouldn't have to get gas for quite a while then, huh? Using the constant of proportionality and then using the equation, determine how many gallons of gas would be needed to travel 750 miles. Well, now I know the number of miles. Remember, the number of miles is y. Y equals miles. So I'm going to use that other equation. I'm going to use this equation over here and bring that one down. All right, I'm going to use that equation because I want to know the number of gallons of gas it takes to go 700. Something's wrong. What's wrong? Oh, I see what I did. I got to go back. I am so sorry, guys and gals. Mrs. Hoekstra made a mistake way back up here. Let's fix this. At least I found it. I'm like, hold it, that doesn't look right. So k is equal to y over, excuse me, x is equal to y over k. and I know that K is 28. So X is equal to Y divided by 28. There we go. Good thing I can work with an eraser and fix things. Whew. I'm so sorry about that, but we fixed it. So here we go. Let's see here. We've got X is equal to 750 over the 28. 750 divided by 28, I wrote 280. Man, I'm having a rough day. All right, 750 divided by 28, and I get 26.8 gallons. I'm going to have to probably go to a gas station because I don't think any cars have 26.8 gallons of gas that they can hold. All right, sorry about the mistakes on that page, but we fixed it and we're good to go. Let's keep going to the next page. All right, look on page 29. Andrea's portraits. Andrea is a street artist in New Orleans. She draws caricatures, right? Those cartoon-like portraits of tourists. People have their portrait drawn and then come back later to pick it up from her. The graph shows the relationship between the number of portraits she draws and the amount of time and hours that she needs to draw the portraits. All right, take a look at that picture, or the diagram, I mean, the graph. You'll notice that time is going across the bottom there, right? And you will see that it looks pretty straight, and it also appears to go through 0, 0. So that should tell me something, right? What do I know about straight lines that go through 0, 0? It says write several ordered pairs from the graph and explain what each ordered pair means in context of this graph. So what we're going to do is we're going to look at that graph. We're going to find places where it crosses nicely between crosshairs. So if you've ever played like Call of Duty or something where you have to, kind of pay attention to the crosshairs of where you're shooting. Not that I'm advocating violence, but right, it goes through the crosshairs really nicely, like right there. So I'm going to put a dot there. That's a data point. It also seems to go through some crosshairs right there. So I'll put a dot there. Keep going up the line. The line also seems to go through those crosshairs right there. All right, and I could include the 0, 0, can I? So let's keep track of our time. We're going to use T for time. And let's use N for the number of portraits. And we have 0 time. She does not make any portraits, does she? And 2 hours, she can draw 3 portraits, right? That's what that one here is, 2, 3. The next one is at where? 4 hours, she can make 6. 4, 6. And in 6 hours, she can make 9. 6 hours, she can draw 9 portraits. Write several equations, it says, to relate the number of portraits drawn to the time spent drawing the portraits. Okay, well, what's that constant of proportionality in the problem above it? All right, we got to figure that out. Well, this is your X, and this is the Y. Remember, I always said it's Y over X to find the constant of proportionality, or in this case, the number of portraits over the time, right? She can do 3 portraits in 2 hours. She can do 4 in 6 hours, which reduces to, 6 over 4. Let's keep it straight here, Mrs. Oakstra. 6 over 4, which reduces to 3 over 2, and 9 over 6, which also reduces to 3 over 2. So my constant of proportionality is 3 over 2. So the time it takes is 3 over 2 times N. Okay? And that's how we could figure that one out. We could also do it as the time it takes is equal to 6/4 over N, right? Or we could even say 9/6 times N. They're all the same, but 3 over 2 is the most accurate. It's the most simplified, so we'll go with that one. Last thing, determine the constant of proportionality and explain what it means in this situation. All right, what is the constant of proportionality? Well, we said it was 3 over 2. What does it mean? This means that she can make 3 portraits in 2 hours, right? Or 3 portraits per 2 hours. Or we could even say she can make 3 over 2, which is what, 1.5, 1.5 portraits per hour, if we want to make it into the unit rate. All right, 1.5 portraits per hour. All right, that's all we have for today. I'll see you all later.